Hello, so this week we're going to talk about atmospheric optics and how the atmosphere interacts with incoming light to create different visual effects. And one of the main ways this happens is through scattering. So scattering kind of comes in three different forms: Rayleigh or Rayleigh scattering, Mie scattering, and geometric scattering. And different particles in the atmosphere are what cause these scattering. So air molecules, nitrogen, oxygen, scatter incoming light, and these particles are 0.001 micrometers. So micrometers are 10 to the minus 6th meters, so significantly smaller than that. This is oxygen, nitrogen, and this results in blue skies, red sunsets as the sun angle becomes lower. So again, that's just one form of scattering. As the particles get larger, you have aerosols, pollutants, and that results in brownish smog. And that's, again, 0.01 to 1 micrometer, and that's Mie scattering. If you ever look at old photos from the 70s in Los Angeles, or even in some cases recently in some parts of the world, you see brownish haze. That's Mie scattering of light. And then as particles get larger and you get up to cloud droplets, which are 10 to 100 micrometers, you get geometric scattering. And this is why clouds look white and puffy, because the light is hitting them and it's changing the form of scattering, and it interacts with all the light rather than preferentially for different wavelengths that represent colors of light.